Another example of being able to work with these systems of differential equations is when we start mixing multiple tanks together with different fluids or different solutions. And you might remember that we were able to do this with first order differential equations. We were able to find the rate of change of a specific concentration of some sort of entity at time t. So now what if we start mixing them together in two or more different tanks? And so let's suppose, for an example, let's say we have two tanks that are connected in a manner illustrated by the diagram below used to mix a solution of water and alcohol. Now, tank one initially has 15 liters of alcohol, and then tank two initially has no alcohol within it. Tank one contains 50 liters of one solution, and tank two contains 25 liters of the solution as well. And the rate of that we change is 10 liters per minute from each tank. All right, so just as a diagram, we know that this tank has 50 liters, this tank has 25 liters of whatever the solution is, and the amount of alcohol. So let's call the amount of alcohol in tank 1x, and let's call the amount of alcohol in tank 2y. Um, and we know that the rate that it flows in to tank 1 is 10 liters per minute, and also the rate that it flows out is 10 liters per minute. Another thing that we can say is that because tank one initially has 15 liters, that means that the function of x at time t is going to be equal to 15. And the function of y at time t, which is 0, by the way, for both of those, is going to be equal to 0, all right, because tank 2 has no alcohol within it. So x is going to be the amount of alcohol in tank 1, and y is going to be the alcohol in tank 2, and both of those are going to be in liters. Right. So let's set up some sort of system to help represent this. All right, and then we're going to go ahead and solve the system. So we know that rate, or the rate, so we're going to say the change is going to be equal to rate in minus rate out. Right? And so let's just say we're looking at the change in the alcohol. All right, so that's going to be dx dt. So that's just going to be the change in tank 1. And we could actually just define that as x prime if we wanted to, which we will. Now, we know that the rate that flows out of the tank is 10 liters per minute. So there's going to be 10 liters flowing out for every 50 in tank 1. And we can just call that x. All right, and that's going to be flowing out, so that's going to be a negative. And what's coming in, all right, so notice that it's going out of tank 1, so it's going in this direction. And then in tank 2, it's coming in from this direction, so that means that we're going to say plus the rate in is 10 liters of the fluid per minute out of 25 in tank 2, which is y. Right? So hopefully that makes sense as to how we set that up. Now, for the change in y, well, that's just going to be flipped, because now what's happening is the directions are reversed. All right, well, the directions are still the same, but for the tank. So we're flowing out of tank 2 at a rate of negative 10 over 25y. So that's what's flowing out. And then what's flowing in is positive 10 over 50x. And again, we still have those initial conditions up top. Right, so this is letter A, this is our system. All right, so just like we did all the way back when we looked at first order differentials, we had rate out or rate in minus rate out. So this is out, and this is in, and this is in, and this is out for the different tanks. Now let's go ahead and solve this. All right, so if we were to just go ahead and use Wolfram Alpha to solve this, this isn't too difficult to be able to do. And I'm just gonna erase some of this stuff that kind of got blended in there somehow. All right, so we're going to go to our Wolfram Alpha. And go back to our home page, and we're going to solve. So remember, we had x prime was equal to negative 10 over 25x, or 50x, excuse me. And then we're going to have plus 10 over 25 times y. So that's our first equation in our system. And our second equation, y prime, is going to be the exact same thing, except we flip the signs around. So y prime is going to be equal to positive 10 over 50x minus 10 over 25y. Right? And I'm putting the multiplication symbols in here because sometimes Wolfram Alpha doesn't pick those up as nicely as we'd like it to. And remember, we said that x at 0 is equal to 15 because there were initially 15 liters of alcohol in the first tank, and in the second tank there was nothing. All right, so let's see what happens with this. And it gives us these two systems. All right, and I'm going to distribute the 5 through there. All right, so what we're going to end up with, and I'm just going to pull this over so we can see our screen, is we're going to end up for part B is that x at t is going to be equal to 5e to the minus 3/5 t plus 10, and y at t is going to be equal to 5 minus 5e to the minus 3/5 t. So that's our solution. And what this tells us is the amount of alcohol in each of the tanks after time t. Okay, so amount of alcohol in each tank after t minutes. Right. So now what we're trying to do is we're trying to figure out the approximate amount of alcohol in each tank after 1 minute. And so what that means is we need to find x at 1, and we need just to find y at 1. All right, so this is for part C. So that's going to be 5e to the minus 3/5 plus 10. And that's going to be 5 minus 5e to the minus 3/5. All right, and again, all we did was we just substituted 1 in right here for t to figure that out. So nice and easy. So I'm just going to go back to Wolfram Alpha, and I'm just going to copy this text, and I'm just going to paste it up right here. And I'm just going to get rid of the t, and I already have x of t right there. So I'm just going to hit enter, and I should get rid of the equal sign here because it's a function, and I think it gave it to us anyway. So 12.744. All right, so this is going to be x at 1 is going to be 12.744, and let's find y at 1. So that's going to be 5 minus 5 e to the minus 3/5. All right, and that's going to give us 2.256. Right, so that's going to be 2.256. All right, now, and by the way, these are each in liters. Right? How do we know if this makes any sense whatsoever? Well, let's add them together. Right? So if we add 12.744 plus 2.256, I'll just do this in Wolfram Alpha since we have it already. So 12. I forgot it already. 12.744 plus 2.256. That's 15 exactly. All right. So if we go back here, this is going to be equal to 15. Now, does that make any sense? Well, remember, if we go all the way back up, remember that the initial amount of the two tanks was 15, all right? And we're just assuming preservation, that we're not losing any of the alcohol due to evaporation or any leaks in the tank or anything of that nature. And so our answer does make sense. All right, so these are indeed the amounts in each tank after time t. All right, now, what is the long-term behavior? In other words, what's going to happen if we run this sort of system for a long time? Which is usually what happens in factories, is that they just run these things for a long time, and we could try to predict what might happen. So what's going to happen eventually is we just take the limit of each of these. All right, so I'm just going to take these guys right here, and I'm just going to copy this down for part D. So I'm lazy, I don't feel like copying it again. And just move it over a little bit. This is for part D. Is the long-term behavior is going to be the limit as t approaches infinity of each of these. All right. And what's going to happen when t approaches infinity to both of these? Well, we have an e to the minus 3/5 t for each of those, and then we have a constant. And we know that as t goes towards infinity, this quantity just becomes 0. So the long-term behavior of this system, and remember, this is represents x at infinity, or that's just the x value, and this is the y value, which is 5. All right, so what does that mean? So that means after a long period of time, or we can say as t approaches infinity, that means that x, which is equal to the liters in tank 1, will approach 10 liters, and y, which is the liters in tank 2, is going to approach 5 liters. All right, so and that again makes sense because there should be a total of 15 liters. All right, so that makes sense to us. And so what that means is, even though this first tank started with nothing, all right, if we keep flowing as given, all right, then eventually we're eventually going to have 5 liters of alcohol in tank 2 and 10 liters in tank 1. All right, so we'll take a look at one more of these types of problems, maybe involving more than 2 tanks, but hopefully this gives you a good overview as to how to try to work with these systems involving the tank problems.